The quadratic formula shown here is a surefire way to solve quadratic equations. The first thing you have to do, though, when you're about to use it is just to make sure that you do have a quadratic equation, because that's the only kind of equation it will work on. So you know it's a quadratic equation if you have an x squared term, or any variable squared, but 2 is the highest power, and you have to have a term that has a square on it. So yes, we do. We have an x squared term here, so we've checked that off our list. The second thing is we need to make sure that our quadratic equation is in standard form. If it's not, we can always fix it. That's no problem. But standard form means that you have a 0 on one side of the equation and everything else is on the other side. So those two checks are done. We're ready to roll. The next thing we have to do is determine what a, b, and c are. So referring to the formula, we see that we've got the three letters A, B, and C. We need to figure out values so that we can plug them into our formula. Now the A value is always the coefficient of your x squared term. In this case, there's no number there, so we know that that's an implied 1. So A is equal to 1. The B term is always taken from your x term. Usually it's in the middle. B is equal to 2. And C is always your constant term. So in this case, it's a -5. Now that we've sorted out those three values, we go ahead and we plug them into our formula. So x equals, and now we have a negative because that comes from our formula, a negative b, and our b value is a 2, plus or minus square root. Now we're going to take our b value and square it. So 2 squared is 4, minus 4 times, and now we want to multiply that by the a value, which is 1, and the c value, which is a -5. All of that's over 2 times our a value. Now we've rewritten our formula, plugging in our numbers for A, B, and C. The next step is to go ahead and start simplifying everything. So we'll start by looking underneath the radical there. Not radical, that's the square root sign. So we have 4 minus a 4 times 1 times a -5, and if we do that over here on the side, we have 4 times 1 times a -5. That's going to give you a -20. So we're actually looking at 4 minus a -20 all over 2. And then finally, let's rewrite that. X is equal to -2 plus or minus square root. And now we have 4 plus 20, so 24 all over 2. Our next step involves simplifying our radical. We want to see if we can actually get rid of the radical by taking the root of that 24. Now, if you just want an approximate answer, you can go ahead and plug that into your calculator and round that off to a certain place and use that number. More often, though, we'd like an exact answer, which means we're going to leave the radical in place, but we're going to try to simplify it. The square root of 24 itself is not a perfect square, so we can't take the square root. What we can do, though, is we can figure out if there's any factor in there which is a perfect square, and there is. So 24 is actually the same as 4 times 6. Square root of 24 is the same as the square root of 4 times the square root of 6, and 4 is a perfect square. So if we take the square root of 4, we get 2 times the square root of 6. Now let's rewrite our formula again. So we have -2 plus or minus, and now instead of the square root of 24, we're going to write 2 times the square root of 6 because we've simplified that radical. One last step, now we want to see if we can do any reducing, and we notice that in our numerator that we can actually factor out a 2. So let's go ahead and do that. We factor out a 2, so let's factor out a 2 times negative 1 plus square root of 6 all over 2, oops, plus or minus. We can cancel the 2's, and we've got our answer. Now one last word of caution and reminder that negative 1 plus or minus the square root of 6, remember that that actually represents two answers. Negative 1 plus the square root of 6 and negative 1 minus the square root of 6. And you're all done.